Assalamualaikum warahmatullahi wabarakatuh. In this video, we will explain about water reticulation design project. This is the list of our group members. First thing first, I will explain about the design assumption. We assume that the hostel have 50% per floor with 360 liters per day per student, and for the cafeteria, they have 6 stores with 900 liters per day per store, and admin building have 1,200 liters per day per 100 meters square with the area 876 meters per square. For the fire floor, they have type class B risk with the number of hydrant outlet is 1, and we use the pipe size is 200 mm with the material high density polyethylene with the roughness coefficient 130 mm.
Water demand calculation. Water demand for hostel that we get is 720,000 liters per day. Next, for the cafeteria, the water demand is 5,400 liters per day. While for the admin building, the water demand is 10,520.16 liters per day. And finally, we get the total water demand for parcel A, which is 735,920.16 liters per day. In order to determine the design flow, we need to find feed flow and fire flow. Based on the calculation that we get fire flow larger than feed flow, thus we use the fire flow as the design flow, which is 5,623,920.16 liters per day. Lastly, the total water supply from the reservoir, which is include parcel A, parcel M and parcel N. The value that we obtain is 13,871,760.48 liters per day.
Reservoir design. The total daily demand that we calculated is 13,871.760 meter cube, where the land area available is 4,000 meter square. The proposed tank area is 2,400 meter square with a tank depth 7 meter, structural height 23 meter, tank properties 40 meter times 60 meter, and the volume provided is 16,800 meter cube. It is shown that the reservoir design are compatible and pass the proposed tank.
This is our design layout. It has been divided into 2 loops and the length of the pipe have been measured using AutoCAD.
Next, for Hardy cross method, we first determine the draw-off of the pipe for loop 1 and loop 2 by using the Q total including the fire risk, ensuring it is sufficient for the area. Moving on to the calculation of Hardy cross method, all the data that calculated are put in this table. The H value for each pipe is determined by using the Hazen-Williams method. Meanwhile, the value of Q prime for single pipe and joining pipe is calculated differently. As we can see from the first iteration, the value of dQ and total H is not equal to 0. Thus, we proceed to the second iteration by using the value of Q prime as the new Q. The iteration is proceed until the value of dQ and total H is almost to 0.
As for residual head, first, we have to calculate the friction loss along the pipe using Darcy-Weisbach equation. We assume F equal to 0.001 and diameter for all pipe is 0.2 meter. Second, we calculate the available head at node F to classify it as main. Then, to gain height for other nodes, we just minus the H node with friction loss. Next, we calculate the top water level using formula and assumptions. Lastly, the residual head is elevation level plus available head minus with top water level, and it must be more or equal to 7.6. These results show that our residual head passed the minimum value, which is 7.6. Therefore, we do not have to redesign.
Conclusion. For the conclusion, the objective of the project are fully achieved, and all the design procedure for this project is successfully passed each of the design requirement. All the proposed pipe system, reservoir, and the design flow is compatible and safe to be used in the proposed layout.
That's all from us. Thank you.